Hello everyone, I am from Narayana Group of Institutions. I am Padmavati. I am going to discuss 28th January first shift of mains paper, which is one of the hardest shifts of these first shift of mains. Okay. So let us go to the first question of this paper. So look into the question which is given. Which of the following oxidation reactions are carried out by both potassium dichromate and potassium permanganate in acidic medium? So both potassium permanganate and potassium dichromate can oxidize iodide to iodine and then sulfide to sulfur, ferrous to ferric, but now the main problem is with iodide to iodate they have given. Potassium dichromate and potassium permanganate in acidic medium oxidizes iodide to iodine, whereas potassium permanganate in alkaline medium it happens to be a better oxidizing agent than acidic medium. That's why it oxidizes the iodide ion to more further higher oxidation state to +5 to iodate. In alkaline medium, potassium permanganate oxidizes iodide to iodate, but not in the acidic medium. This we can observe it as a wrong statement, and thiosulfate ion is oxidized to sulfate ion by both potassium dichromate and potassium permanganate. It is also a correct statement. So, we should have the correct set of options as A, B, C, E, but we do not have among the given choice all the 4 statements. So, the more correct wherever D is there I am eliminating. D is there, D is there, D is there in 1, 2 and 4th options. Hence, the correct option is the third option A, B, C and C only, right. So, let us go to the next question. A good question conceptually. Look into the about the nucleophilic substitution reactions. They have given us statement 1. So, the given, observe it as a tertiary amine containing chlorine as a leaving group will undergo alkaline hydrolysis at a faster rate. So, than you can say given you can say a simple primary alkyl halide, right. Is it a correct statement? The statement 1, it is a correct statement. What is the reason? Intramolecularly, first we can observe that the nitrogen that is present here at beta position, we call it as neighboring group participation. It attacks intramolecularly as SN2, the lone pair of nitrogen will attack on the chlorine, forming a 3-membered cyclic intermediate like this. So, which is favorably cleaved by the nucleophilic attack by aqueous KOH, alkaline hydrolysis. So, because of this neighboring group participation of nitrogen, so it occurs at a faster rate than where there is no neighboring group participation, or we call it as ankymeric assistance is possible in the second compound. So, statement 1 is a correct statement. How about statement 2? So, the given alkyl halide where there is a neighboring group participation, they are giving that intramolecular substitution takes place first by involving the lone pair of electron on nitrogen. Actually, it happens to be the correct explanation for the statement 1. Why the first compound is undergoing faster rate than the second compound. So, hence you can identify that both statement 1 and statement 2 are correct. The option is here, both statement 1 and statement 2 are correct statements. Let us go to the next question. Look into this. So, the metal ion whose electronic configuration is not affected by the nature of the ligand. That is one set of the question, one part of the question, and which gives a violet color in non-luminous flame under hot conditions of borax bead test they are asking about. So look into the metal ion for actually in the octahedral field from D4 to D7. There is a difference in electronic configuration in strong field and weak field, but from D1 to D3 and D8 to D10 there is no difference in electronic configuration whether it is strong field or weak field. And moreover, the second clause they are asking about is in borax bead test, the metal borate ion that is formed which will give the violet color in oxidizing flame they are asking. Non-luminous flame happens to be the oxidizing flame. So let us see one by one. They are asking about Cr3 plus. So Cr3 plus means chromium electronic configuration is 4s1 and 3d5, an anomalous configuration in the ground state. Then Cr3 plus configuration is first remove from the biggest principal quantum number, then you will get it as 3d3. So therefore, whether it is strong field or weak field, we will write it as T2G3 is 0. There is no difference. And moreover, the Cr3 plus metal borate ion, that is the composition Cr metaborate ion BO2 taken thrice, which is the composition of the colored bead in the borax bead test, happen to be a green color. So hence, even though the first part of the question is satisfied, the second part, that is green coloration, is not satisfied. Hence, we are violating the Cr3 plus option. So how about titanium plus 3? So titanium plus 3 in the ground state, titanium electronic configuration 4s2, 3d2. Titanium plus 3 means it is 3d1. Only one unpaired electron is there. Hence, whether it is a strong field or a weak field, it happens to be the same electronic configuration. Here also, the first part of the question is satisfied, but not the second part again, because the in borax bead test in oxidizing flame, the titanium metaborate happens to be, you can identify reddish brown color. Hence, color is not satisfied. How about, so this is also not satisfied. So how about nickel plus 2? Nickel plus 2 means nickel in the electronic configuration, the nickel ground state 4s2 3d8. So nickel plus 2 is 3d8. Whether it is strong field ligand or weak field ligand, we write the electronic configuration as T2G6 and Eg2. So the first part of the question is satisfied, and nickel metaborate ion, nickel metaborate happens to be a violet color complex. So that's why we can go with the nickel plus 2. So once let us check the fourth option also. Ni2 plus is the answer. Is there any possibility that Mn2 plus is also satisfying? Means Mn2 plus is ground state 4s2, 3d5 is manganese. Mn2 plus means always remove from the biggest principal you can say quantum number, the electrons. So 4s is removed, then you are getting 3d5. But the 3d5 electronic configuration, if it is strong field T2G5 is 0, but if it is weak field T2G3 and Eg2. Even though the manganese metaborate ion, metaborate compound, so which is the composition of the colored bead, the manganese metaborate, even though it is violet colored complex, but the first part of the question is not satisfied. Hence the correct answer happens to be 3. Okay. So they asked on memory base of the color also. This is borax bead test. Definitely it happens to be a typical question. So look into the next question. They are asking about the compounds that produce carbon dioxide with aqueous sodium bicarbonate. All the acids which are stronger than H2CO3 can liberate carbon dioxide from aqueous sodium bicarbonate. All carboxylic acids happens to be stronger acids than H2CO3. Hence, they can liberate carbon dioxide, but not phenols. But as the electron withdrawing groups like NO2 groups are substituted on phenol, their acidic strength can increase. 2,4-dinitrophenol as well as 2,4,6-trinitrophenol which is picric acid, can liberate carbon dioxide from aqueous sodium bicarbonate but not the simple phenol. Hence, you can say benzoic acid can liberate carbon dioxide from aqueous sodium bicarbonate but not the simple phenol. Its acidic strength is not strong enough to liberate carbon dioxide from aqueous sodium bicarbonate. This option C given is a picric acid. C can be given. And D is a benzoic acid, it can be given. I think it should be A and D seems to be same options, but in the original paper it seems to be a simple cyclohexane carboxylic acid. Originally they have given, it's a typo error. And look into the option E, you can say paramethoxyphenol. Moreover, there is a plus M group dominating. The acidic strength of this paramethoxyphenol is less than even simple phenol. So, when phenol itself is unable to liberate the carbon dioxide from aqueous sodium bicarbonate, obviously the paramethoxyphenol cannot. Hence, the acids that can liberate are A, C and D. The options where we have A, C and D is the second option. Let us go to the third question, next question. Look into. So, based on the type of the redox reactions, they have framed a question, look into, which is a little bit of simple question only, right. So, methane on combustion giving carbon dioxide and water, this comes under simple combination reaction of a simple element and a compound of methane and oxygen to give carbon dioxide and water. It's a combination reaction which is a redox reaction, and which is a combustion reaction. You can identify this is coming out to be a combustion reaction. Next, sodium hydride decomposing to sodium and hydrogen, which is a thermal decomposition reaction. So, you can match this with a thermal decomposition reaction. And look into option C, the vanadium pentoxide reacting with calcium to give vanadium and calcium oxide, means the high electropositive metal can displace less. You can identify the once again, that is you can say the more electropositive metal can displace the less electropositive metal. So, from its metal oxides, hence calcium can reduce vanadium pentoxide to vanadium. Hence, it is coming out to be a displacement reaction. And look into hydrogen peroxide decomposing into water and oxygen, where it is coming under a disproportionation reaction, means within the same species you are finding the same element. Here it is oxygen, which is with -1 oxidation state undergoing both reduction and oxidation. Hydrogen peroxide, the oxygen with -1 oxidation state is undergoing reduction to -2 and oxidation to 0. Hence, I can match this with disproportionation reaction. So, you can identify that A is matched with Q and B is matched with R decomposition reaction, and C is matched with the displacement reaction and D with the P. Hence, option 4 happens to be the, you can say, the correct option. Look into the next question, right. They are given in a multi-electron atom, which of the following orbitals of the 3 quantum numbers will have the same energy in the absence of electric and magnetic fields, they are saying. So, such type of orbitals which have the same energy in the absence of electric and magnetic fields, we call them as degenerate orbitals. So, look into the given quantum numbers are representing which atomic orbitals. N is equal to 1, L is equal to 0 and M is equal to 0 means it is representing 1s atomic orbital. It is representing 1s atomic orbital, and N is equal to 2, L is equal to 0 means it is representing 2s atomic orbital. N is equal to 2, L is equal to 1 means it is representing 2p atomic orbital, and whereas n is equal to 3, L is equal to 2 means it is representing 3d atomic orbital. Whereas magnetic quantum number ML, they have given it as 1, means it can be dyz or dxz, but you can write it is a 3D, whether it is an xz or a yz. Whereas n is equal to 3, L is equal to 2 means it is also representing 3D. So mainly when ML is equal to 0, it is 3D z square. But in the absence of magnetic field, all the 5 d orbitals of d subshell are degenerate. Similarly, in the absence of electric and magnetic field, all the 3 orbitals of p subshell are degenerate. Similarly, degeneracy of F subshell is 7. So hence D and E options, because both of them are representing the 3D atomic orbitals, they happens to be of same energy. Okay. So look into the next question. Right. So this is from colligative properties. So very repeatedly we are getting the problem from depression in freezing point and elevation in boiling point. They are asking what is the freezing point depression constant of a solvent where 50 grams of which, take the data correctly in the physical chemistry problem. That is the main important task. 50 grams is the weight of the solvent, 1 gram is the weight of the non-volatile solute, and decrease in freezing point, that is delta TF is 0.4, they are given. So from that data, what is the formula we have to choose? So the formula we have to write is delta TF is given by I into Kf into molality, where I is representing the Van 't Hoff factor, but in this problem, because they didn't mention anything about the nature of the solute, whether it is an electrolyte or a non-electrolyte, by default we are considering it as a non-electrolyte, and we are considering when nothing is mentioned about the nature of that non-volatile solute, whether it is dissociating or not associating, by default we are taking the Van 't Hoff factor as 1. So now delta TF they have given as 0.4, I value 1, Kf value they are asking you to find. What is the freezing point depression constant, means that molar depression constant they are asking about, Kf, which we can also call it as cryoscopic constant. Molality, number of moles of the solute, weight of the solute is 1 and molecular weight of the solute is 256 they have given into 1000 by weight of the solvent in grams they are asking about. So therefore relatively seems to be the simple calculations only. Hence we are finding Kf value is coming out to be 2.56 into 2, which is coming out to be 5.12 Kelvin Kg per mole. Hence the correct answer happened to be the second one. So relatively the calculations are also easy. This is one of the question easily the students can afford. Next, look into the next question. A typical question from the organic chemistry, the combination of 2-3 concepts. Once let us verify. They have given a molecule P on treatment with acid undergoes rearrangement and gives Q. Q on ozonolysis followed by reflexing under alkaline conditions, they are saying that the compound R is formed and they have given the structure of R. In such type of questions, we have to do the back steps. Look into, so this is the structure of compound R obtained after, you can say, ozonolysis followed by alkaline conditions. So immediately what it should strike in our mind, ozonolysis, okay, is giving a diketo or a dicarbonyl compound which under alkaline conditions means it is undergoing aldol condensation. So the resultant product R is given is aldol condensation resultant product. So let us do the back steps. So aldol condensation product is always alpha, beta, unsaturated aldehyde or a ketone. Alpha, beta, unsaturated carbonyl compound I got. Now, to get what is its corresponding, you can say the compound which is intramolecular aldol condensation undergoing by which we are getting the compound R. So from I am cleaving that to get the structure of the compound Q, which is undergone aldol condensation, this alpha beta unsaturation, I am doing reverse aldol condensation, retro-aldol condensation. From alpha carbon, what are involved in alpha carbon? Acidic alpha hydrogen. So give two acidic alpha hydrogens, okay, and to the beta you have to give the carbonyl group, right. So this by intramolecular aldol condensation we are getting the resultant compound R. Okay. Now Q on ozonolysis followed by reflex under. So what should be the structure of Q? Q on ozonolysis means do the back steps. So Q will be here, right. So wherever these double bonded oxygens are there, to get to the structure of Q, which is an alkene, remove those double bonded oxygens and join them by a double bond. So therefore, how many membered as a result, how many membered ring is formed here? So let us observe here the membered ring is here 1, 2, 3, 4, 5, 6. I am getting a 6 membered ring like this. I am getting a 6 membered ring, 1,2 dimethyl cyclohexene I am getting. So this is the structure of Q. Now which of the following among the given 4 options as a starting compound P, right, can form that resultant compound Q they are asking about. So look into the first one. Already it is, they have given it as an alkene and a 6 membered. So already they are asking about the structure of P, but they have given in the option 1 structure of Q, hence it is not the correct one. Look into the second one. If I am by acid, if I am removing this OH group as water, I am getting a positive charge on a 4 membered ring directly, which cannot be expanded to get a 6 membered. I should get the structure Q, right. So therefore, look into the possibilities. For this particular question, I think NTA has given the option 4, but 3 is also equally possible. What is the reason? Okay, NTA option is given answer as 4, but 3 is also possible equally. Look into in acidic medium by electrophilic addition, the carbocation mechanism, you are getting the tertiary carbocation like this. So I am getting a tertiary carbocation. So do the ring expansion. I am getting 5 membered ring expanded to the 6 membered ring, and then followed by 1,2 methanite shift I am getting, and followed by deprotonation I am getting the resultant compound Q. Hence option 3 is also equally possible, right. Similarly option 4. So again I am wherever OH is there, I am making it as a better leaving group by protonation on OH group, I am getting a positive charge. Now look into the stability of the carbocation. I have positive charge here. How many number of hyperconjugations are possible? And now you make out as here hydride shift and followed by ring expansion and then 1,2 methanite shift, then also you can get compound Q. Hence both option 3 and 4 are possible for this question as the correct answers, right. So look into, it could be 3 or 4 for this. Okay. So look into the next question. So all important areas of the typical conceptual points they have touched in this particular shift. From biomolecules, they are given statement 1. D-glucose pentaacetate reacts with 2,4-dinitrophenyl hydrazine, which we in shortcut we call it as 2,4-DNP. Brady's reagent. 2,4-DNP is a reagent used to test the carbonyl compound. Any carbonyl compound can give a precipitate with 2,4-DNP. But in spite of D-glucose, D-fructose, they have a carbonyl group, but because they are involved in ring formation by hemiacetal ring closure, okay, hence these weak nucleophiles like 2,4-DNP, so they are not giving the positive test for the identification of aldehyde or ketone. D-glucose itself cannot respond to the 2,4-DNP. And moreover, they have given D-glucose pentaacetate cannot react with or any identification test for 2,4-DNP. Even D-glucose pentaacetate cannot react with hydroxylamine also further to give oxime. Hence, statement 1 is a wrong statement, right? So, don't think that because D-glucose in its open chain structure, it has an aldehyde group, we can detect it by 2,4-DNP. No. Okay. These carbohydrates, D-glucose, D-fructose, you cannot detect for carbonyl compound by 2,4-DNP. Statement 2. Starch on heating with concentrated sulfuric acid at 100 degrees Celsius, you are getting glucose. Yes, starch is made up of with glucose units, where many glucose units are joined by alpha glycosidic linkages. In starch, you will find. So, where this formation of glycosidic linkage means it is an acetal formation. Acetals can be cleaved in acidic medium. So, hence in presence of sulfuric acid, the acetal linkage can be cleaved and hence you can get glucose units. It's a correct statement. So, where statement 1 is false, but statement 2 is true. The second option is correct answer for this. So, let us go to the next question. Right. So, which is an excellent question from the kinetics. You can enjoy in doing such type of logical based question. So, without struggling this numerically, so you are finding, see, most of the questions they have given 4 options and asking you to select how many of those options are correct, like that they are asking. Now, look for as per the given data. They have given initial concentration versus half-life time. So, easily the numbers are friendly only. So, you identify when initial concentration is decreased by 4 times, 0.1 is becoming 0.025. As initial concentration is decreased by 4 times, what is happening to the half-life time? Half-life time is decreased by 2 times. So, if you are very quick in calculations, immediately you can identify that it's the order of the reaction is half, 0.5 order. Order can take the fractional values also. It is not the 0 order or second or a third order. Okay. What is the known formula conclusion for us? Half-life time is inversely proportional to initial concentration power n minus 1. T half is inversely proportional to, you can say, a power n minus 1. So, if I want to prove this by formula also, if you are unable to find immediately by numbers, put it in the formula. T half 1 by T half 2 will be, you can identify T half 1 by T half 2, 200 by 100 will be equal to A2 by A1 whole power n minus 1. I can write it as A2 by A1 0.025 by 0.1 whole power n minus 1. So, therefore, what you can identify? So, as a result, look into the calculation. This is 0.025 by 0.1. You can get it as 1 by 4, and a 2 power 2 power n minus 1, you are getting it as 2 power minus 1. Do the calculations. So, from this also, the order of the reaction you can conclude it as it is a half order, right? Hence, option A is a correct among the given one. Look into option B. If initial concentration is 1 molar, then T half is 200 root 10 minutes. So, without making the calculations complicated, so look into the numbers given. So, you take the reference of any one of these two, right? I am taking 0.1 initial concentration as a reference. Now, the concentration has become 1 molar they have given. Means how many times the concentration got increased? if I am taking 0.1 as a reference. 0.121 means 10 times the concentration is increasing. If concentration is increasing by 10 times, half-life time should, you can say, if concentration is increasing by 10 times, half-life time should increase by root 10 times. Because what is the order of the reaction? Half, no? Order we are taking to the power. So hence it comes out as root 10 times. So to the 200, you multiply with root 10. Again, don't make the typical calculations there. Just look into the numbers there. 0.1 has become 1 means 10 times the concentration is increased. Hence, because the order of the reaction is 1 by 2, the half-life time should increase by root 10 times to that of the 0.1. So 200, simply I am multiplying with root 10. So that is the logic they are expecting to do if they are giving in mains, means obviously time is very less. So that's why quick calculations you have to do. Next, look into the next one. So option B is also a correct choice here. The order of the reaction changes to 1 if the concentration of the reactant changes from 0.1 to 0.5 they are given, right? So the concentration does not affect the nature of the reaction, that is, order of the reaction is not affected by concentration. Hence it's a wrong statement. We are not selecting among the correct answers. Next, look into the T half is 800 minutes when initial concentration is 1.6 molar they have given. Again, take the reference of these two. I am taking the reference of 0.1, 200. So 0.1 has become 1.6 means how many times the concentration is increased? 16 times. If the concentration of the reactant is increasing by 16 times, half-life time should increase by root 16 times. Because the order of the reaction is 1 by 2. Root 16 means 4. Therefore, 200 I am multiplying with 4. Hence, half-life time is coming out to be 800. So, with such type of simple logic, if you solve this problem, so within a minute you can solve, because the maximum time we can spend is here 1 to 1.5 minutes if you are confident about that question. So, look into, therefore, the correct choice are C should not be there, A, B and D. We are getting as correct answers. Now, look into the next question. Yeah, the incorrect decreasing order of atomic radii they are asking about. So, they have not given all across the period or down the group like that. So, they have mixed the orders of the two groups, okay, the two periods, second and third. So, let us verify here. If I am writing the second period element, beryllium, boron, carbon, nitrogen, oxygen, fluorine. The third period elements, the respective elements, if I am writing magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. So, we know that across the period atomic radius decreases up to the 17th group, and down the group generally atomic radius increases. So, if I am checking the first option here, aluminium greater than boron. This is down the group. So, aluminium greater than boron is a correct one, and then nitrogen greater than fluorine across the period. So, hence it is a correct answer. But they are asking about the incorrect. So, look into the second choice. So, look for the second choice here. Beryllium greater than magnesium they are given. Beryllium greater than magnesium. Obviously, with the first two elements only easily you can identify that beryllium is less in atomic size than magnesium. Down the group, no, it is. So, here it is failed. Beryllium should be less than magnesium, magnesium greater than aluminium, aluminium greater than silicon. Hence, second one happened to be the incorrect order and correct answer. How about here? Silicon greater than phosphorus. So, silicon greater than phosphorus is correct one across the period, no? And then chlorine greater than fluorine. That is also a correct choice. magnesium greater than aluminium across the period again, and aluminium greater than carbon, carbon greater than oxygen, right? So, third and fourth are correct statements and incorrect answer. Second one is the incorrect statement and correct answer. So, let us go to the next question. Yeah. So, look into the molecules having square pyramidal geometry they are asking about, right? Just simply in such type of questions, don't adopt any shortcut formula. Look into the number of valency electrons on the central atom. So, what they have given, bromine from 17th group, it has 7 valency electrons. Out of 7 valency electrons, there are 5 bond pairs. How many number of atoms are attached to the central atom? Simply that many number of bond pairs we have to count as per the Vespo theory. Whether they are bivalent or a trivalent, a double bond or a triple bond, as per the Vespo theory, we have to consider it as one bond pair to get the correct geometry of the, you can say, given molecule. 5 bond pairs, out of the 7, 5 are used, 2 non-bonding electrons which I am calling it as one lone pair. The total steric number is coming out to be 6. Everything you can say. So, 6 means immediately I will say is equal to total number of hybrid orbitals sp3d2. Obviously, they didn't ask about the hybridization, of course. So, immediately you should get in your mind the resultant structure. 5 bond pairs, 1 lone pair means it is square pyramidal, right? The alignment of all the electron pairs is octahedral, but the resultant geometry of the given molecule is square pyramidal. PCl5, 5 bond pairs, 0 lone pairs, trigonal bipyramidal, right? So, PCl5 is not suiting into square pyramidal. Next, SbF5. So, antimony pentafluoride, it happened to be 5 bond pairs, 0 lone pairs. Hence, you can say it is trigonal bipyramidal. PCl5 also trigonal bipyramidal. So, hence it is not a correct set. 5 bond pairs, 1 lone pair, square pyramidal. Again, look into xenon oxytetrafluoride. In case of xenon oxytetrafluoride, on the central atom xenon, how many valency electrons are there? 8. Out of 8, how many are involved in bonding? From oxygen 2, from 4 fluorines 4, total 6 electrons are involved. But while you are counting as bond pairs, so what we have discussed, whether it is a double bond or a triple bond which is oriented in one particular direction, you have to consider it as one bond pair. Hence, total bond pairs are how many? 5. What I am saying, irrespective of the nature of atoms attached to the central atom, whether they are monovalent, bivalent or trivalent, you consider that many number of bond pairs. Total 5 atoms are attached to the central atom, that many bond pairs. 5. So, out of 8, 6 electrons are used, 1 lone pair, right? Hence, 5 bond pairs, 1 lone pair means again it is square pyramidal. 5 bond pairs and 1 lone pair happens to be the square pyramidal. Xenon oxytetrafluoride is square pyramidal. This is one of the lone pair, square pyramidal. How about antimony pentafluoride? This is again trigonal bipyramidal. So, this is square bipyramidal. So, where we are finding that both the given species are square bipyramidal is in option 3. A simple Vespo theory based question from chemical bonding. So, definitely every student expected to answer this, a simple question. Look into the next one. So, in such type of questions, so little bit on experimental, CBSE laboratory manual also you have to go through once you look into this question. In the oxalic acid versus potassium permanganate titration, the solution needs to be heated initially to 60 degrees Celsius. When permanganate and oxalic acid, in oxalic acid, oxalate ion gets oxidizes in acidic medium to carbon dioxide and permanganate itself gets reduces to Mn2+. I have not written a balanced equation because not required now, right? permanganate oxidizing oxalate to carbon dioxide and itself getting reduced to Mn2 plus in acidic medium. So, in this question what they are asking, initially heated to 60 degrees Celsius. So, actually this reaction initially will be slow, but as the more amount of Mn2 plus is forming, the reaction will become faster. So, hence it require initially some heating. Why gradually the rate of the reaction increases means due to autocatalysis. Mn2 plus act as a autocatalyst, right? So, which further increases the rate of the reaction. So, that is why it requires a slight warm conditions initially. But in case of ferrous ammonium sulfate, so in case of ferrous ammonium sulfate, permanganate oxidizes ferrous ions to ferric ions in acidic medium. Obviously, itself gets reduces to Mn2 plus. Ammonium ions, they doesn't undergo any change. Sulfate ions, they are not undergoing any change. Only ferrous to ferric. But if you are heating this, so it can undergo aerial oxidation. The means in presence of air, the oxygen present in air can oxidize Fe2 plus 2 to Fe3 plus. So, our analysis may go wrong because we want to, you can say, analyze this qualitatively as Fe2 plus. But if Fe2 plus is getting oxidized to Fe3 plus, you cannot get our redox reactions properly. So, look into the statement 1. Titration, the solution needs to be heated, it's a correct one. But no heating is required in case of ferrous ammonium sulfate. What is the problem if you are keeping for heating ferrous ammonium sulfate? Ferrous ions can get oxidized to ferric by aerial oxidation, right? So, very clearly they have explained in statement 2 the reason for the statement 1 also, but in this particular session none of the question they have asked as assertion and reason type. That is little bit advantage. Statement 1 and statement 2 both happen to be the correct statements here. So, where that option we are finding, both statement 1 and statement 2 are correct in this particular question, right? Let us go to the next question. So, they have given the elements from 13th group and 14th group: indium, thallium, aluminium, lead, tin and germanium. A little bit memory based. Okay, ionization enthalpies. First ionization enthalpies of 13th and you can say 14th group. So, strictly they are asking about only the general characteristics of the P block elements, remaining all compounds and all deleted for mains. So, they are restricted to only general characteristics, that is about the ionization enthalpies they are asking. So, indium, thallium, aluminium. Among these, thallium happens to be the highest, 13th group. Among the three, lead, tin and germanium, you can identify germanium happens to be the highest, right? And between the 13th group and the 14th group elements have high ionization enthalpy. So, highest you can say ionization enthalpy is germanium, highest first ionization enthalpy. As per the NCERT tabled values that they have given for the first ionization enthalpy, highest first ionization enthalpy is germanium, whereas least ionization enthalpy is for indium as per the values. This is the lowest ionization enthalpy, right? So, then what is the stable oxidation state for germanium? Germanium, tin and lead, they can show both +4 and +2 because their general outer electronic configuration is NS2 NP2. They can show both +4 and +2, but for lead +4 and +2. What is the stable oxidation state for germanium? +4, tin +4. That is why SnCl2 happens to be a good reducing agent. But for lead, the stable oxidation state is +2. What is the reason? Due to, you can say, inert pair effect, lead is stable in +2. Okay. And for germanium, it is +4. So similarly, if you are going for gallium, indium, thallium for the 13th group, which is Ns2np1 is the general outer electronic configuration. These also can show +3 +1 +3 +1. The stability of +1 increases down the group due to inner pair effect. Gallium and indium are stable in +3, thallium is stable in +1. So, but I think NTA has claimed the answer for this question as +4 and +1, but as per highest ionization enthalpy is for germanium and least for indium. Indium is stable in +3, so we can go with +4 and +3. We can claim the answer as +4 and +3, but NTA given answer is this +4 and +1. Recently released key +4 and +1, but we can go with the values as per NCERT +4 and +3. Let us go to the next question. So this is clearly given in NCERT also, this particular concept, right? Ambident nucleophiles, right? So when an alkyl halide is reacting with, let us say I am taking Rx, an alkyl halide reacting with potassium cyanide, we write that the major compound we are getting is alkyl cyanide, whereas alkyl nitrile as the major product you are getting. Whereas the same alkyl halide, if it is reacting with AgCN, the major compound is isocyanide. Isonitrile is the major product. What is the reason for it means? How we can explain? Potassium cyanide happens to be a very good ionic compound. Hence, the nucleophile we consider is readily in the ionic form cyanide. Hence, carbon happens to be a better donor atom. Hence, because carbon-carbon bond is relatively stronger than carbon-nitrogen bond, it preferentially prefers to binds with carbon. As carbon-carbon bond is stronger than carbon-nitrogen bond, and the nucleophile is readily available in the cyanide form. Hence, carbon tries to bind with the alkyl group. So, alkyl cyanide will be the major product. But whereas in case of AgCN, so this is not highly you can say, whereas AgCN, it is not highly ionic, it is more covalent in nature. So carbon is engaged partially by binding with the silver. Hence, nitrogen is relatively free, so it happens to be the better nucleophile. Hence, on the demand of the, you can say, the substrate, nitrogen happens to be the better donor, and finally this bond cleaves. Hence, isocyanide will become the major product. Same happens here. You can say the same thing can happen in case of the ambident ligand or ambident nucleophile with the nitrite. So when you are taking nitrite here, if it is reacting with potassium nitrite, again it's readily available in the ionic form, NO2 minus, it happens to be oxygen will become the better donor, this will be the major product. But when it is reacting with silver nitrite, identify here. So, but when it is reacting with silver nitrite, one second, reacting with the silver nitrite, nitrogen happens to be the better donor, right? The same reason, this is more ionic, potassium nitrite, okay, but here nitrogen will become the better donor. Identify here, as a result, nitroalkane you will get as a major product. Here alkyl nitrite you are getting as a major product when potassium nitrite, but when silver nitrite is there, nitroalkane you will get as a major product. So with they are asking A and B respectively, that also you look carefully. So A should be nitroalkane, and whereas B should be isonitrile. Hence, the correct answer we can go is here with option 1. Let us go to the second question. So, look into. So, get the meaning of the question correctly, what they are asking about. So, consider N is the number of lone pair of electrons present in the equatorial position of the most stable structure of ClF3. In case of trigonal bipyramidal alignment, always lone pairs preferentially occupy the equatorial position to minimize the lone pair repulsion and lone pair bond pair repulsion. So, in case of ClF3, you can identify that total out of 7 valency electrons, 3 are involved, 3 bond pairs and 2 lone pairs. So, hence the resultant structure happened to be the T shape. You can identify the 2 lone pairs preferentially occupy the equatorial position. This is ClF3, which is T shape. So, there are 2 number of lone pairs. Here number is important for us. They are not asking about the structure and all. N is equal to 2 here. The ions from the following with N number of unpaired electrons they are asking about. Again you have to go with the simple, you can say, electronic configuration of these transition metal ions. Vanadium plus 3 they have given it as. So, vanadium plus 3, vanadium 4s2, you can say 3d3 plus 3 means. So, cancel the 4s, always first in first out. Okay, while you are filling, you will be filling 4s first, while you are removing also 4s first, first in first out. So, 4s you remove here. So, I am left over with vanadium plus 3 as, verify here, 3 unpaired electrons. And how about titanium plus 3? Titanium identify it as here 4s2 3d2. In case of titanium, titanium plus 3 you are getting it as here 3d1, right. Copper plus 2, copper is here 4s1 3d10, copper plus 2 is here 3d9, where number of unpaired electrons are only 1. How about nickel plus 2? Nickel is here 4s2 3d8, nickel plus 2 is 3d8. Number of unpaired electrons are 2. Titanium plus 2. Titanium plus 2 is, just now we have done titanium. Titanium plus 2 will become 3d2. If I am writing titanium plus 2, it is 3d2. So, hence number of unpaired electrons are 2 for titanium and for nickel. D and E you can identify. So, vanadium they have given it as plus 3. Oh, plus 3 no, 4s2 3d2. Yeah. So, if I am removing 3 electrons, even vanadium is also satisfying. Yes, vanadium is also satisfying. So, total A as well as D and E, you are finding that total number of unpaired electrons are 2. Hence, I can go with the option A, D and E, right. So, look into the 67th question. Both acetaldehyde and acetone individually undergo which of the following reactions they are asking. Can they respond for iodoform reaction? Iodoform is a test for identification test for alpha methyl carbonyl group, CH3CO group. Among the aldehydes, simple aldehydes, among the aldehydes, only acetaldehyde will respond to the iodoform. Hence, acetaldehyde will respond, and acetone, it has the structure of CH3C double bond O. Hence, it will also respond to iodoform. I can select A. Cannizzaro reaction. Cannizzaro reaction is given by the aldehydes not containing alpha hydrogens, because both acetaldehyde and acetone have alpha hydrogens. Okay, they does not respond to the Cannizzaro reaction. Both of them can undergo aldol condensation because they have acidic alpha hydrogens. Yes, they can undergo. Tolerance test. Tolerance test is given by aldehydes only but not ketones. Hence, acetone will not respond to the Tollens silver mirror test. Clemmensen reduction. So, both acetaldehyde and you can say ketone, they can undergo Clemmensen reduction in presence of zinc amalgam HCl, where C double bond O group is reduced to CH2 group. As a result, you can identify that acetaldehyde will give ethane and acetone will give propane by Clemmensen reduction. So, hence both acetaldehyde and acetone can respond to iodoform, aldol condensation as well as Clemmensen reduction. We have A, C and E only, option 4. So, let us look into the question number 68 here. The correct order of stability of the following carbocations they are asking. So, in deciding the stability of carbocation, all these factors we consider: aromaticity, stability by resonance, hyperconjugation, inductive effect, all these factor matters. Now, identify among these, so give the priority to the aromaticity, the tropylium ion among the given species highly stabilized. Among the given 4, highest stabilized by aromaticity. Next, the positive charge can delocalize with these 3 benzene rings. Resonating structures can be resonance with all these 3 benzene rings, right? So, hence you can say more resonating structures I can write for structure A. Next, 2 benzene rings, resonating structures I can write B, and lastly D is stabilized only by hyperconjugation and inductive effect, no resonance stability or aromaticity stability. So, 5 hyperconjugative structures you can write and also inductive effect stability. So, therefore, the correct option you can go is here C greater than A, greater than B, greater than D. So, look into the next one from ionic equilibrium. So, they are asking about, look into. So, question seems to be a little bit fresh and new, some of these questions of this you can say particular shift. HA is a weak monobasic acid. Look into HA is a weak monobasic acid ionizing into H plus and A minus. Now, what they are asking about? So, where X is the degree of dissociation, because the problem is given as degree of dissociation, initial concentration you can consider it as 1, right, because the problem is made with the degree of dissociation, no need to consider it as C also, right. So, if I am writing it as at equilibrium directly, at equilibrium, what I will get? Out of the initial concentration 1 I have taken, okay, the degree of dissociation is X, this is X and X, right. Then what is the expression for Ka you can write? So, Ka is equal to, you can write concentration of H plus into A minus by Ha, means X square by 1 minus X. But they are asking the value of pH minus pKa. So, I want what is minus log of H plus. So, what is the concentration of H plus? Is X. So, concentration of H plus I am getting it as, which is X, will be from X square, I am writing it as X into X means, right. If I am writing X square as X into X, I am separating one X as concentration of H plus. X is equal to Ka into 1 minus X by X. So, I want the expression for pH, apply negative logarithm on either side, minus log of concentration of H plus will be minus log of Ka minus log of 1 minus X by X. So, it is minus log of H plus is nothing but pH, minus log of Ka is pKa, I am bringing on the left hand side, minus pKa, which is equal to minus of log 1 minus X by X. If I am reversing the fraction, I can write it as plus log of x by 1 minus x you can make out as. So hence you can get it as log x by 1 minus x. So hence your option will become, the correct answer will be the fourth one. Now look into the next question. So this is the most general question they asked about, for which typically you won't find any answer in your NCERT content like that, what they are asking about. So they asked, ice and water are placed in a closed container at a pressure of 1 atmosphere and temperature 273.15. So obviously at these conditions you will find that water in the solid state and water in the liquid state will be in equilibrium. So which we are calling it as the at melting point, these two phases are in equilibrium at 1 atmosphere and you can make out as 273.15 Kelvin. So to discuss this as per general, so water in solid state has more volume, that's why ice floats on liquid water, and water in liquid state has low volume. So increase in pressure actually shifts the equilibrium to low volume side, lower volume side, right? As a result, you can identify that increase in pressure decreases the melting point, right? And moreover, you should have an idea about the triple point of water also. Based on water phase diagram, you will find that at when pressure is doubled to 2 atmosphere, completely it can exist in the liquid phase only, okay? It completely exists in the liquid phase only at 2 atmosphere based on the water phase diagram also. Hence, more correctly, even though you may feel that the amount of ice is actually getting decreased here, but when one of the option is to be chosen, the solid phase disappears completely, will become the more, you can say, correct answer. One should have the idea about the water phase diagram to answer this also. At 2 atmosphere and 273.15 Kelvin, that is around 0 degrees Celsius, it completely water exists in the liquid phase. So hence the more correct answer will become the solid phase disappears completely, right? So all the single option questions are completed. So let us move to the typical part, that is integer based questions. Look for it. So they have given, verify here, the formation of enthalpies of atomic hydrogen gas and oxygen gas they have given. Once you take the data carefully, then the problem will become very simple. What do you mean by the enthalpy of formation of hydrogen atomic gas means? You can verify it as H2 gas, you can say, dissociating to give nascent hydrogen atoms. So enthalpy of formation of hydrogen means per 1 mole of hydrogen atom formation, how much amount of energy required they are given? 220 kilojoules. For 2 moles of hydrogen atoms formation, you double the value, it becomes 440 kilojoules. So how about, you can say, oxygen diatomic gas, it is giving oxygen, you can say, is dissociating to give 2 nascent oxygen. So here also for 1 mole of oxygen atoms formation, 250 kilojoules of energy is required, double the value, 500 kilojoules, right? So now the equation that we will take for the formation of water is hydrogen in gaseous state and oxygen in gaseous state combining to give water in the liquid state. This is the thermochemical equation I should take for the standard enthalpy of formation of water, where for this the enthalpy of the reaction, delta H of this reaction, how much they have given? Minus 242, which is equal to, if I am writing the enthalpy of the reaction in terms of bond dissociation enthalpies, sum of the bond dissociation enthalpies of the reactants minus bond enthalpies of the products. So, what are the bond enthalpies of the reactants? Hydrogen, hydrogen bond enthalpy. This is what the equation we take for the bond enthalpy of hydrogen. I got 440 plus half into 500. This is sum of the bond enthalpies of a reactants. So, from this what I have to subtract? In water there are 2 OH bonds are there in water. If each OH bond enthalpy, if I am supposing it as X, that is 2X kilojoules, if I am founding it as 2X. So, from this you calculate the X value, what you are finding it as the average bond enthalpy of the OH bond in water at 298.15 kilojoules they are asking about. So, verify it as minus 242, 440 plus 250 minus 2x, you are given it as. So, how much it is? It is coming out to be 440 and 250. So, it is 690. So, minus 242 and 690, it is coming out to be, you can say 932. So, hence 2x is 932, hence x value you can write it as 932 by 2, which is coming out to be 466 kilojoules per mole. Okay. So, not at all difficult calculations. So, if you are clear with the concept of this thermochemistry, how to calculate the enthalpy of the reaction in terms of bond enthalpies, and but here there is a little bit complicated point, that is they have given enthalpy of formation of atoms of hydrogen and oxygen, from which you have to take the bond enthalpy of hydrogen and oxygen. So, your answer happens to be 466 kilojoules per mole. So, let us move to the next question. Yeah. So, this is from electrochemistry. So, taking the data only very important in solving the physical chemistry problems carefully, what they are correctly asking, what data they have given. So, they have given d by Huckel-Ohnsager equation, molar conductance versus square root of concentration. So, it is the resultant equation is molar conductance. This is in the form of y is equal to minus mx plus c a into root c. This is what d by Huckel-Ohnsager equation we are writing. So, you are given here at a low concentration 0.1, the conductance is 150, whereas at a high concentration 0.15, the conductance is 100 they have given. Now, look into the problem and what they are asking correctly. If for the higher concentration of KCl solution, the resistance of the conductivity of the cell is 100 ohms. So, what formula I can use here? Molar conductance equal to, I have to take the help of two formula here. Molar conductance equal to specific conductance K into 1000 by molarity. This is the one formula I have to use, and specific conductance equal to conductance into cell constant, G into G star we write as per NCERT notation. Conductance means I can write 1 by resistance into cell constant. Now, directly I am comparing here molar conductance of, let us compare here directly. So, molar conductance of low concentration by high concentration. Molar conductance, if I am taking low concentration by high concentration. Low concentration at 0.1, what is the molar conductance? 150 by high concentration 100 is equal to, actually I have to write K1 by K2 into M2 by M1. But if I write in terms of resistance, same cell, so cell constant is constant, it is not a variable. What I can write? K is inversely related to resistance, specific conductance. So, hence I can write which is equal to R2 by R1 into M2 by M1. So here only in doing the calculations you should be very cautious here, right? So mostly mistake can arise only in the calculations here. You know the formula but substitute the values correctly. So what you are given 150 by 100, I can write it as here, I identify 150 by 100 is equal to, what I have taken 150 is the conductance at low concentration, it is at high concentration. I have done low by high. Now what I have to write? Resistance and concentrations I have to write high by low. So resistance at higher concentration they have given 100 by low I have to find into M2, high concentration 0.15 and low concentration is 0.1, right. So verify here, high concentration by low concentration, and for higher concentration the resistance of the conductivity cell they have given. So if you are solving for it, verify here what is the R1 value, you can get it as, you are getting the value as 150 here. Once you check the calculation, the resistance for 0.1 concentration, because the calculations are simple, you are getting it as 150 ohms, right. So let us move to the next question, right. So directly based on the concept of formula of molarity, the molarity of 70% mass by mass they have given. What do you meant by 70% mass by mass? 70% mass by mass means 70 grams of the solute in 100 grams of solution. If I take 100 grams of solution, in that 70 grams is the solute, right. Then they are asking about the molarity value. So molarity is the number of moles of the solute present in 1 liter of the solution. So number of moles, weight of the solute 70, molecular weight is 70 into 1000 by, I require volume of the solution in ml. But I have not given volume of the solution directly. What I have in my hand? I have mass of the solution and I have density of the solution. So volume you can identify it as mass by density. So mass of the solution as 100 by density. So that goes to numerator 1.25. So very friendly numbers, just you cancel. So you can identify it as, you are getting it as 12.5 is your answer. But look into the question carefully what they have given. They are asking about the x value into 10 power minus 1. So I can write this as 125 into 10 power minus 1. Hence our answer is 125. Okay. Right. Look into the next question. So they have given quantitative analysis of an organic compound, simple, based on empirical formula and molecular formula from basic principles of chemistry. So let us observe the data. You are given carbon, you are given chlorine, you are given hydrogen, you are given, first these three you verify what are the percentage composition by their mass. Percentage composition, their mass is 14.5 is carbon and 64.46 is chlorine, 1.8% is hydrogen. Don't be in a hurry. Is this sum is coming out to be 100? No. Then remaining percentage, subtract, add all these three and subtract it from 100. Remaining by default is, it is understood that it is oxygen. Most of the times if oxygen is present they don't give you. You sum all the given percentage of the elements, composition by mass. If that is not coming out to be 100, remaining percentage is oxygen. So if I am getting, I think around 19.24, if I sum all these and subtract it from 100. Then what is the relative number of atoms? What I have to do? I should divide them with their respective atomic weights. So 14.5 by 12, 64.46 by 35.5. What I am doing? To get the relative number of atoms, I am dividing the percentage composition by mass with their atomic mass. And 19.24 you divide with 16. So these values are coming out to be approximately 1.2 here. So I am taking the help of this 1.8. So I may get one of the number as 1.8. This is also nearly 1.8 and this number is 1.2. So hence the simplest whole number ratio of these atoms, what I will get it as here, 2, 3, 3, 2. Hence I am getting the empirical formula as C2, Cl3 and H3O2. Then what is this empirical formula weight? I will get it as. The empirical formula weight I am getting it as 24 plus 35.5 into 3, 106.5 plus 3 plus 32, which is happening to be, it is coming out to be 166.5 around, which is, but they are asking about 166.5 into 10 power minus 1. Hence our answer can be 1665 into 10 power minus 1. So you are asked about this number. 1665 can be the answer. Let us look into the last question, but not least, a very good question from the organic chemistry. Look, verify. So you are given an aryl chloride, chlorobenzene, with magnesium with dry ether. You are getting first by the first step Grignard reagent. I am getting phenyl magnesium chloride, which is a Grignard reagent. So this is on attacking with carbon dioxide. Now Grignard reagent is playing the role of a base. Grignard reagent in all the organic reactions plays only two roles, either as a base or as a nucleophile. So here its majority role as a base first, right? Because it cannot have any acidic hydrogens to abstract, it is acting as a nucleophile. As a nucleophile it is adding here. So as a result I am getting a benzene carboxylate ion followed by acidification, I am getting here benzoic acid, followed by acidification, I am getting benzoic acid. So benzoic acid on heating with ammonia, first it will undergo acid base reaction. I will get an ammonium salt of benzoic acid, but on further heating I will get benzamide. I am getting benzamide. So obviously when you are looking into the further arrow mark as bromine in alkaline conditions, you should immediately identify the reaction as Hofmann bromamide degradation. So A is an amide which is benzamide undergoing Hofmann bromamide degradation. The resultant product B is an aromatic amine, primary amine, which is aniline. So in all these reactions you will identify that if I am starting with 1 mole of the reactant aryl halide, I will get it as 1 mole of the product aniline. 1 mole will give you 1 mole of aniline. So they are asking the number wise calculation, stoichiometric calculation wise they are asking about. So 11.25 milligrams of chlorobenzene they have given. So the molecular weight of chlorobenzene, so from benzene, one hydrogen I am removing 77, to that I am adding 35.5, this is 112.5 grams. And whereas molecular weight of aniline Molecular weight of aniline is again to the 77. I am adding 1 nitrogen 14 plus 2 16 NH2 group 14 plus 2 16. So, I am getting this as 93 grams. So, 112.5 grams should give 93 grams, and how about here they have given 11.25. So, 11.25 grams means it is 0.1 moles, right? Anyhow, whether it is grams or milligrams, they have given here milligrams and asking also milligrams, no problem whether grams or milligrams, right? Same answer we will get. So, for 0.1 millimoles, I should get 0.1 millimole. So, for 11.25 milligrams, I should get 9.3 milligrams. I should get here 9.3 milligrams. So, but the answer asked is here most of the questions framed like this only, 93 into 10 power minus 1. Hence, our answer happens to be 93. So, these are the excellent questions of 28th January first shift. So, with which I have completed this discussion. See you all later. Have a good day. Thank you.